Okay, continuing to move forward, we've looked at converting from exponential to logarithmic and vice versa. We looked at how the properties worked with natural logs. Now we're going to actually solve some equations that deal with a base of e or deal with the natural log. So the first property that we're going to use on this slide is this one on the right here, natural log of e to the x equals x. I'll show you kind of how that works down at the bottom as a general proof. And then I'll show it again when we actually solve one of these problems. So if I have natural log of e to the x, I'm saying it is equal to whatever x is. So in this case, if you're given the right side over here, or excuse me, the left side over here, where I have natural log of e raised to some power, in this case they call it x, x would be the answer that would come from this. Okay, so now where does that all come from? I'm going to get rid of a few things on here. Okay, I'll have to keep that box. But to give you kind of a proof of how this works, remember the natural log in here is the same thing as a log base e. So now I have a log base e of e to the x, and we're still saying it's equal to x. And since we've dealt with a lot of converting, we're going to convert this from a log to exponential. So my base in this case is going to be e, this one. Remember, log means what's the exponent, which in this case is x, should equal to e to the x. When is e to the x equal to e to the x? Well, that would be always. So in order to make this a true statement, we need to state that, going back up here to the top, if I want to make this all work, the natural log of e to the x has to be equal to x. That will be the value. Okay, so we're going to use this property to solve these two problems. Okay, so let's look at the left one. Notice where my variable is. It's in the exponent. So I'm solving for an exponent. That's probably where we're going to need to use natural logs. Your goal is to get e to the 4x by itself. So we're going to add 12 over, then divide by 3. We'll do those in separate steps. So I have 3 e to the 4x equals, add that over, you're going to get 27. Now to get e to the 4x by itself, we're going to divide both sides by 3. E to the 4x equals, when I divide, I'm going to get 9. Okay, now here's where this gets even more important. So now I have e to the 4x equals 9. And remember, if I want to pull that exponent down, so it's kind of on the same playing field, I'm going to take a natural log on both sides. Remember, one of your properties, if I use the property from section 5, looked like this. Okay, remember that was the third property. Remember what that does is it allows me to take my exponent, which in this case is n, and move it out front. Okay, so we're going to use that same idea with, instead of a log of some random base, we're going to say we're going to use the natural log, because e and natural log are inverses of each other. So now I have natural log of e to the 4x equals natural log of 9. If I take a natural log on one side, I've got to take a natural log on the other side to keep it equal. And that allows me to take my 4x and move it out front. So 4x natural log of e equals natural log of 9. Now here's where I want you to take your calculators, because this is super cool. There was a reason that we took a natural log on both sides, and I want you to see that relationship. Remember, natural log is the same thing as log base e. Okay, so if we take our calculators We're going to try this. You're going to have to find your natural log button right here, ln. And I'm going to take natural log of e. Again, you might have to put e to the first. And that's going to get us 1, which is super, super helpful. Okay, so it's like natural log of e just disappears. Let's use this color. It's like it just disappears. It's 4x times 1, and anything times 1 is whatever that something was. So now I have 4x equal to natural log of 9. Okay, now why was the natural log of e just 1? Why did that work? Well, I'm going to do that off to the side over here first before we move on. Okay, so we're saying that the natural log of e is equal to 1. Why? Okay, kind of the same idea that we did before. I'm going to prove it to you. Remember, natural log of e is the same thing as log base e of e. Okay, remember, and we're going to say that it is equal to 1. And we're going to convert this to exponential again. My base is e, that's this one. My exponent is 1 equals e. What would the exponent have to be on this side for them to be equal? Remember, we would always try and drop, once we had this scenario, I can call it x for now. Whenever we had like bases, what did we do with the bases? We dropped them and set our exponents equal to each other. So in this case, x equal 1. Okay, so whenever we have natural log of e, we're going to say that it is the same thing as the value of 1. Okay, last step over here. Now I'm returning back to our original problem. I want to solve for x. To solve for x, we're going to take and divide both sides by 4. X equals now the natural log of 9 divided by 4, which is something that you can plug into your calculator. They wanted to the 10,000th place, which is 4 decimals. If you plug that into your calculator, you will get 0.5493 is the value. I'll plug it in myself so you can see that. Natural log of 9 divided by 4, move this out of the way, equals, there it is, 0.5493. All right, we're going to do one more, just so we can make sure that we understand how this works. I'm going to erase all of this. We're going to look at 4b now. Okay, one more. Same idea, I want to get e to the negative x by itself. So I'm going to have to subtract 8 and then divide by 4. We'll go through this one just a little bit quicker. So now I have 4e to the negative x. If I subtract 8, that's going to get me 9 out of the deal. Then I'm going to divide by 4. I'm not going to really divide. I'm just going to show it. So now I have e to the negative x equals 9/4 out of the deal. Remember, if I want to pull the exponent down, I'm going to take a natural log on both sides. So now I have natural log of e to the negative x equals the natural log of 9/4. That allows me to pull the exponent out front, so negative x, natural log of e equals natural log of 9/4. Again, natural log of e is just 1. So now I have negative x equals natural log of 9/4. And then to get x by itself, we're going to take everything times a negative 1. And if I take everything times a negative 1, that's going to get me x equaling negative natural log of 9/4. Make sure you put parentheses around that when you plug it into your calculator. X comes out to be 0.8109. And that's solving an equation with a base of e.